Pre-algebra lesson 116, area of parallelograms and trapezoids. Okay, so I believe I've already told you guys the way we find area of parallelograms is base times height, right? So the area is going to be the base times the height, and the way they're explaining that right now is by showing you the double triangle dissection. And if you remember the proof, or well, the example on how we found the area of a triangle, it was the triangle. If you were to double it, it's always half of the quadrilateral that it creates, right? And that's what we see here with this parallelogram. It's just two triangles broken in half, right? So they're doing a quick review on that. So to find the area of a parallelogram, we would just have to take the length of the base. So in this case, the length of the base is 6 and multiply it by the height. Now the thing you have to remember is the height is always the vertical length that goes straight up and down, right? It's not always the number on the side. It's whatever number is next to this 90-degree angle and goes straight up and down. So the base here is really easy to see. It's 6. The height, some of you might get confused and think, oh, it's going to be 4. No, the height is the straight up and down distance. It is not always the same length as the side. So here the height is 6. So the area of this parallelogram would be 6. Or sorry, the height is 6. Here the height is 3. So the length of this parallelogram would be 6 times 3, which would give us a total length of 18 inches squared. Great. So the reason why we bring all this up and we go over the two diagonal triangles thing is so that we can learn how to find the area of a trapezoid. But before we do the area of a trapezoid, let's just do a quick practice problem for area of a parallelogram. So I've got the following parallelogram. It looks like this. I can see the actual parallelogram is traced right here. And then I've got these extra dashed lines with this little 90-degree angle here. So if I remember, the formula for area of a parallelogram is going to be base times height. So here I see the base is 9, the height is 4. 6 is not helpful. I'm not going to use it at all. So now I do 9 times 4. That gives me 36. I didn't give you any units, so the answer is just going to be units squared, because that's how we measure area. Okay, so that's the quick recap on how to find the area of a parallelogram. Now, the reason why that's important to view in the context of cutting it into two equal triangles. Let's say that I were to do the area of each triangle individually, triangle 1, triangle 2. What would that do? Well, what that would do for me is I would also see that this, since it's a parallelogram, this is also going to have a height of 4, right? The height is the same. It works both up and down. And since it's a parallelogram, the side's also going to be 9. So if I was going to find the area of triangle 1, I would have to do 9 times 4 divided by 2, which I could cancel these, right? That would be 1, that would be 2. 9 times 2, okay, so that would give me 18 units squared. Now if I did the second triangle over here, I would have to do the base times height divided by 2, so it would be 9 times 4 again divided by 2. That would cancel, and then I end up with 18 units squared again. So if I wanted to find the total area of the parallelogram, or the quadrilateral, I would just have to add 18 and 18. And what do you know, if I add 18 to 18, I get a final answer of 36 units squared, right? When I add 18 plus 18, I get 36. So you still get the same answer either way. Now, why in the world would I go through all of that trouble when I could just do base times height? Well, this rule that I just showed you, where I find the area of one triangle, add it to the area of the other, also works for trapezoids. Now, trapezoids, you'll remember, are quadrilaterals that only have two parallel sides. And trapezoids can be a little bit funny, because I can't just multiply a base times the height, because it's different. But what I can do is I can use that same logic I just pulled from the parallelogram, which is I can cut it into two triangles, right? So I can cut it into two triangles, and I can find the area of each triangle individually and then add them. So what that means for me is, for this triangle, I'm going to have 11, which is the base, right? I have to view it upside down, and if it helps, you can also turn your paper upside down. So I see this is the base, and the height is going to be whatever this distance is. Ah, I see the height right there. It's 5. Okay, so the area of this top triangle, triangle number 1, is going to be 11 times 5 divided by 2. Well, when I multiply that, well, how did I get all off focus and blurry? When I multiply that, I end up with 55 over 2, which is just going to equal 27.5 units squared. So that's triangle, or yeah, that's triangle 1, 27.5 units squared. Okay. Next, I would have to do the same thing for the other triangle, triangle number 2. So for triangle number 2, I see the base is 14. The height is again going to be 5, right? That's one thing they share in common. They're always going to have the same height. So then I'll do 14 times 5 divided by 2. Hey, 2 and 14 cancel into 1 and 7. 7 times 5. Well, that gives me 35 units squared. So now I've got, for triangle 2, 35 units squared. And if I add that to 27.5, I get my total area. So let's see here, 27.5 plus 35. That's going to be 0.5, carry the 12, 62.5 units squared, and that is my total answer for the entire trapezoid. So this is the logical way that I can find the area of a trapezoid. I can just remember, okay, I need to cut into 2 triangles. That's a base, that's a base, that's the height. I'll get both those triangles and add them together. Now there is a faster formula that we can use. All right, I'm okay with you guys solving it logically. That is perfectly fine. That's the method that your book recommends. There's also another formula that you can memorize. Right? So the other formula that you can memorize is right here. It's base 1 plus base 2 in parentheses times the height divided by 2. So what this does is this combines the formulas for both triangles into one formula. So the way that I would solve this one is I would call this base 1, this would be base 2. Whoops, wrong colors. Oh well. So what I would do is I would have 11 plus 14. That would be in parentheses. I would multiply that by the height of 5, because remember, they both had the same height. And then I can divide that number by 2. Right? So here, if I do PEMDAS, 11 plus 14, I end up with 25. Okay, so now I have 25 times 5. 25 times 5, ooh, that's 125. And then I have 125 divided by 2. Okay, let's do that math over here. 125 divided by 2. 2 goes into 12 6 times. I have 5. 2 goes into 5 2 times with 1 left over, which is going to be 62.5 units squared, which is the same answer we got down here. Okay, so there's 2 different ways we can approach areas of trapezoids. We can either do it logically by cutting it into 2 triangles, or you could memorize this formula and then make sure you properly identify base 1, base 2, and your height. And then again, this 6 and the 7, useless. We do not need this information. All right, that's it for this lesson. If you guys have any questions, let me know on the school website, and I will see you in class.